Bismillahirrahmanirrahim. This is going to be the third video lecture in a mini series of lectures discussing about the irrationality of a square root of 2 by means of contradiction, proof by contradiction. Now, the proof by contradiction is that whenever the direct proof of a statement is a bit difficult, we may approach it by proof by contradiction. That is, a statement is we take the negation of a true statement as our assumption, and then based on that we continue. Let me repeat one more time. We take the negation of a true statement, whatever statement it is. In this case, a square root of 2 is not a rational number, and we based on that assumption we continue. Then a good curious question that you may ask, or a curious student may ask, is that okay, I make assumption that a moon is made out of green cheese. Nothing wrong, that is a statement. But when we go through the logical process, we go and land on the moon, and we notice that the surface is solid and we can walk. So moon is not made out of green cheese. So our statement that moon is made out of green cheese, the negation of that is that moon is not made out of green cheese. That will be the case for us, because we demonstrate that moon is not made out of green cheese. Now, the beauty of mathematics and logic is that when a statement is false, when our assumption is based on a false statement, the conclusion will reject it. It's a fascinating, science of logic and mathematics. Meaning that some weird or some absurd conclusion we will end up that contradicts the assumption to be the case. And that is exactly what we are going to do here. So let's see how we approach it, if I may. Let me now zoom this one in for you, stay out of way, so that we lecture it on the board. Right? Okay, here the statement that we start with, as I already mentioned, is that the square root of 2 is not a rational number. We know that is true. The negation of that is that a square root of 2 is a rational number. So our assumption will be based on this statement, which a square root of 2 is a rational number. So if a square root of 2 is a rational number, then must satisfy the definition of rational number. And the definition of rational number is that any number that can be expressed or can be represented as P over Q, ratio of two integers, where in our case, the P and Q are natural numbers. So we don't have to work with the negative integers. So if we have to show that a square root of 2 can be represented that way. If we can, then yes, then our negation, the negation statement will be true. But we know that will not be the case. Okay, I have written this one. Now let's go over that if you like to write. So we end up with that. We want to show that a square root of 2 can be represented as a P over Q, and see what happens. So the rest is, next one is this. Let me go and see if it is zoomed or it needs to be a little bit. Oh, it's good. Okay. Now here, Our assumption is that the square root of p, square root of 2 can be represented as a ratio of p over q, where p and q are natural number. This notation means belong to natural number, and n stands for natural numbers. 1, 2, 3, 4, 5, 6, and so on. So the rest of them is just simple what? Simple algebra. So what we do, when two things are equal, their square will be equal. So we square both sides. Remember that the converse of that is not true. So when we square this side, we end up with this 2 equals to p square over q square. Again, very elementary algebra. We multiply both sides by q square, and we end up with this algebraic expression. 2q square equals to p square. Are you with me so far? Now, let's go now to the next one, which is the continuation of 2q square equals to p square. Okay, now the left-hand side of the equation is even. Why? Because it's multiplied by 2. And don't forget q square are all natural numbers. So if the left-hand side of equality is even, the right-hand side must also be even. So that means p square must be even. And if p square is even, that means p must be even. You follow me? Like if a number is odd, a square of that is also odd. Like 3 square is 9. 5 square is what? Is 25. So if a number is odd, a square of that is odd. If a number is even, a square of that is even. Therefore, p must be even, because a square of that is even. So I write that one in this form. P equals to 2m, where m is a natural number. By the way, I have something here, let me say, because I'm giving this lecture for the kind of beginner basic algebra and college algebra. I'll go a little bit in more detail. So let me go now to this one, if I may. Now here, p is an even number. I write it in the form of 2m. Now here, m is a natural number. So if m is 1, m can be any number we select. As far as natural number we are selecting. So I select some 1, 2, 3, 4, 5, 6, and so on. Then 2m, look at that, will be 2, 4, 6, 8, 10, 12, and so on. So we can write p in this form. We can write p in this form, and let's see now what we can get out of it. Now, writing p in that form, p equal to that, then what happens? Then 2q square will be 2m square, because p, now here, we replace it with 2m. Because p is an even number, so that will be 2m square. Do you follow me? So instead of p, I write it in that form. Now, look what happens. I raise this one to the power, I get 4m square, and I simplify, you see that? And I simplify 2 and 4, becomes q square equals to 2m square. Do you follow me? And right now, contradiction has already occurred, in a sense that we are going around the circle. Now, q square equals in the form of even number. You see that? Q square equals to 2m square. Therefore, q must be an even number. Because q square is even, q must be even. So in q, we write it in the form of q equals to 2n. Again, with the same analogy that I just mentioned, q can be written in this form. Now look what happens. We wrote p in this form, 2m, and we end up to write q in this form. Now look what happened for the next. think I should go ahead and zoom this one so that we can see it better, if I may. Good. Okay, now let's go back to this. We have that P is 2m. You agree, huh? Q is 2n. So a square root of 2 in the form of P over Q, we write it 2m over 2n. Because 2m is P and 2n is Q. Do you follow me? Now the 2 and 2, they cancel each other. So a square root of 2 now is written in the form of m over n, which is simplified form of P over Q. Let me go over that also to show you what I mean for that. You follow me so far? Let me repeat one more time. A square root of 2 equals P over Q, and we end up that P is in this form and Q is in that form, 2m over 2n. Now, when we cancel 2 and 2, then m over n is same as P over Q, but in a simplified form. So, example that I have is this one, if I may. Like, for example, if I have 24 over 40, I divide numerator and denominator by 2. We get what? 12 over 20. But 12 over 20 is a simplified form of 24 over 40. Do you follow me? And that is exactly what we are doing here. So we simplify, and that's so we end up a square root of 2 now is equal to what? Is equal to m over n. So we continue the exactly same thing what we did before. So we square both sides. Do you follow me? Exactly what we did before. We are repeating that one. We square both sides. We end up with what? We end up with 2n squared equal to m squared. Now the left-hand side of this equation is even. Therefore, m must be even. Do you follow me? So if m is even, we write it in the form of 2m prime, let's say. You could say 2l or something. I selected prime. So m equals to m prime. And the same is, now we write 2n squared equals to what? Instead of m, we write 2m prime. We end up with 4m prime squared. Do you follow me so far? So here we end up that when we simplify, we divide both sides by 2, we end up n squared equals to 2m prime squared. Is that right? And then n will be what? N should be, n is an even number, therefore we write n in 2n prime form. So you see that we write m in this form, exactly what we did before. And we write n in this form, both of them. Now, the same thing is going to repeat again. Now look what happened. Now look what happens here. A square root of 2 we started to be in the form of P over Q, where P and Q are what? Are integers. Then we simplify because they have 2 in common, so we end up with a square root of 2 to be in the form of m over n, which is simplified form of that. Again, we did exactly the same thing for that, and we end up with 2m prime over 2n prime. So again, they had 2 in common, we factor. Do you follow me? They cancel each other, excuse me. So right now, a square root of 2, P over Q, is same as m prime over n prime, but m prime over n prime is the simplified form of P over Q. All right, let me now go over this and see what I mean by that. I have more complicated that. Okay, now look what happened here. I have an example, 24 over 40. Suppose this is our P and over Q. You see that? Then 2 they had in common, I cancel, I end up with 12 over 20. So in our example was m over n. Again, this they had 2 in common. I factor and I end up with 6 over 10. You see, I end up with this one now. Then I can go further and end up with m double prime. And end up with finally, eventually, I end up to the n. Is that right? There is impossible you can go forever when you simplify numerator and denominator. After a few steps, you end up with numerator and denominator to be relatively prime, which means the only factors that they have in common will be 1. Because all the factors that they had in common in the previously, they already cancel each other when we wrote them in a prime factorization form of that natural number. So that is a clear contradiction. This symbol means contradiction. And why? Because algebraically this can continue forever. This can continue forever. So if you write a computer program and give it a do loop, the computer, of course the computer will recognize that, and after a few words, it will give you error. But if it doesn't, you let him run, the computer can run forever for this procedure, will never. So that contradiction and the contradiction indicates that our assumption was false. So let me zoom this one back. Okay, there is another version coming for the next lecture. I will do that. But this one and the previous lecture I gave, they are equivalent. The same logic, but it's just for having a bit more practice and having more gaining a little bit more muscles. But anyhow, I thank you for watching, and as always, I wish you prosperity and good health, and please stay safe. And also don't forget that your comment, any suggestion you may have, mention it in the comment section below, and that will be, I welcome them. And there is always room for teaching enhancement, and you will be doing a favor to me, and you will be doing a favor to the students that I give lecture, so that they get a better lecture. Please do not hesitate to write your comment, and if you want me to give any lecture of your interest, please indicate that in the comment section below, and I will be happy to prepare a lecture for that. Okay, then again for the second time, I thank you for watching, and have a great pleasant day. So long.